And thank you for the invitation. I'm going to talk about a project called Port Air. We went through a few iterations of what to call this project, and then we settled on the obvious because we are studying the air in the port of Dublin. So the background for this is that we know that ships emit a lot of pollutants, and there was a concern that the port, Dublin port, being close to the city, will have a negative impact on the health of people in the city because of all those emissions. And we know those emissions are going to be there, but the question is, will they impact the city? So there's going to be SO2, lots of PM 2.5, NOx, of course, and there's going to be various, this is heavy fuel that is being burnt in these engines, so there's going to be metals, heavy metals as well, fairly high heavy metal content. So Dublin Port in the foreground, it's a big area, and the city is right behind it. So it's a natural assumption that we're going to have transport of pollutions from the port into the city. But you can't just assume things, you have to try and measure things. So at the beginning of this project, we went up to Dublin Port and we met with the Dublin Port company. This is the original team, and we've had another member since. And they took us on a tour of the port so that we could get a good idea of the activities in the different parts of the port and how to. The first thing we had to do was to decide where does it make sense to do our monitoring. So this was at the beginning of the project. I don't know about the others, but I feel a lot older now. I haven't even had time to cut my hair since we started this project, but it was really helpful to get that tour. And we looked at the kind of shipping activity that goes on in Dublin Port. And to a first approximation, all ships are ferries. That is in terms of numbers, ships, numbers of different types of ships, the ferry traffic is dominating, followed by the container traffic. So we thought it made sense to position our monitoring here near the ferry terminals. So we picked a spot on the eastern edge of the port, because that will capture, of course, all the emissions from the eastern side of the port and also the city behind it. But it also gives us the opportunity to kind of separate emissions that are coming from the sea as well as from the city. We also had a network of PM monitors around the periphery of the port, but I will not include that in today's talk. So at that point, we set up this monitoring station and packed it full of instrumentation, and we started monitoring and measuring. And that went on for 14 months. For the last few weeks, we extended the measuring capability with an instrument in this picture, which is called an exact. It's just an instrument that measures metals in the aerosols with very high time resolution. So we got hourly values. And as I said, metals is going to be a big an important thing to keep an eye on if you're looking for shipping emissions. So all in all, we got lots of data. We got a good chemical characterization of the organic aerosol. This is what Jurgita was talking about earlier. We got the metals. We had detailed chemical characterization of filter samples. John showed some pictures earlier of these filter samples. We had similar ones, and we measured gases and black carbon. And with all this detailed chemical characterization, coupled with statistical analysis, we can estimate quantitatively the different contributions. So we can then separate the contribution from shipping emissions, from the solid fuel burning, and the trucks and the cars, and natural sources and secondary aerosols. I'm not going to give you those figures today, because they're not finalized. But we are. I'm going to give you some general observations and some early indications. And we heard earlier that Ireland is lucky in terms of the geographical location, and we have lots of wind, so we can expect that whatever emissions that are there are going to be rapidly removed, diluted by wind. And that is generally true, except for some pollutants, the opposite is true, and especially for ozone is something that we see more ozone the higher the wind speed. We see the same for SO2, and that's interesting because that's SO2 in gas form. And we see the same for PM2.5, where you have an initial dilution. The higher the wind speed, the PM levels actually drop down, but then when they get really high, we actually get an increased levels again of PM. So we have a combination here, I think, of local and transported emissions that we are picking up here at the edge of the sea. So I'm just going to give you some observations. If we look at the difference between pollutants that are coming from this direction versus those that are coming from the city and port side. And what's interesting here, I think, is that well, we can compare the average of the pollution when the wind is coming from here or when it's coming from the city and port side, which will include both the city emissions and the port emissions. What we see again, as we saw for the wind speed, is that ozone, sulfate, and the very, very small particles are actually there in greater numbers or levels when we have the marine air coming in. We also can look at the species that we measured in our filters, and the story is quite similar there in that we see more sulfur, nickel, and a lot of organic carbon in the marine transported air masses rather than from the city and port air masses. The vanadium and nickel are important when it comes to ships, so we looked at the shipping plumes, if you like. We have the shipping schedule. We know when the ships are there, so we can look at our record, and we can see when the vanadium and the nickel they peak, and they coincide with ships berthing. So these are good markers for ship emissions, which means that we can then start relating the pollutant levels to the shipping activity. But we also have the organic characterization, and this green curve there is just showing again the time series of organic aerosol with these high peaks that coincide with plumes. But what we realized is that all plumes are not the same. Ships burn different fuels, and they create different types of shipping plumes. And this is a new observation, and the thing that is important with that is that traditional markers for ship emissions are no longer enough to identify them, because the fuel that ships use now has to be low emission. But the emission, it's the emission of sulfur dioxide. So either they have to use low sulfur fuel, or they can use the high sulfur fuel and scrub out the SO2. But they have different chemical signatures, which is actually something that we need to take into account when we are developing the final estimates. So I'm finished now, just 10 seconds. We have general observations. We see a lot of transported aerosol. We see that the non-port ship activities are very important. And in fact, the city potentially has a bigger impact on the air quality in the port than vice versa, because the port is downwind. Now, that's not to say that we don't see a lot of emissions from ships. We do. There's a lot of emissions from ships, but they don't reach the city as far as we can see yet, most of them. And this is an important result that we will definitely that was very important. This is one of the most important results, I suppose, scientifically, is that we have two types of ship plumes. So I'll stop there, but we have to thank Dublin Port Company for being very helpful. We're very grateful to Stena Line for their help as well, and of course to the EPA for funding it. Thank you.